Starship operation, bringing it right here to Florida's Space Coast. Its new facility, called Gigabay, is expected to bring hundreds of jobs and the promise of a launch by the end of the year.
A colossal factory rising at Kennedy Space Center is rewriting the rules of rocket production. Imagine a structure so vast it dwarfs skyscrapers, designed to build dozens of massive starships simultaneously. This is no ordinary facility, but a game-changer that could make space travel routine. What happens when relentless innovation meets unmatched scale? NASA's veteran engineers watch in awe as SpaceX's Florida operation pushes beyond anything they've ever seen, promising to launch humanity farther and faster. But this story is only beginning, and the stakes couldn't be higher. Revolutionizing rocket manufacturing. At the heart of SpaceX's Florida operation stands a structure so immense it challenges imagination. The Gigabay. Rising 380 feet tall and encompassing over 46 million cubic feet of space, this colossal factory is purpose-built to upend traditional rocket production. Unlike past aerospace efforts that produced rockets one at a time over months or years, the Gigabay is designed to assemble 24 Starships and their massive boosters simultaneously in dedicated work cells. These cells function like independent assembly lines, each staffed and focused on different stages, enabling parallel production on an unprecedented scale. This transition from sequential to parallel manufacturing is a game-changer. Instead of waiting months just to finish one rocket, multiple vehicles can be in various stages of construction under the same roof. The efficiency gains are not incremental, they border on revolutionary. Think of it not as handcrafted prototypes, but as mass-produced aerospace vehicles. Akin to how car factories transformed transportation on Earth. This promises a rocket industry shift from bespoke, limited builds to rapid, repetitive manufacture. The Gigabay wasn't designed in isolation or on a whim. It represents Starbase 2.0, the culmination of lessons painstakingly learned at SpaceX's original Texas facility. Weather delays, workflow bottlenecks, and equipment clashes experienced there informed every inch of this Florida structure. The factory is weatherproofed, strategically arranged for seamless materials flow, and equipped with smarter crane paths to eliminate previous inefficiencies. This shows a matured industrial vision, built on hard-earned ops experience rather than hopeful experiment. Elon Musk's often stated ambition to produce thousands of Starships isn't fantasy, it's mathematically feasible with Gigabay's design. Each of the 24 cells can handle multiple parts or sections yearly, meaning production numbers could realistically soar. This redefines the industry's scale, from dreams of sending humans to Mars to practical means of building the spacecraft necessary to do so. The Gigabay effectively bridges the gap between present-day prototyping and full-scale spacecraft commoditization. This facility is more than a factory. It's a cathedral dedicated to rocket production. Its sheer size evokes awe, but the real ingenuity lies in converting that volume into rapid, reliable manufacturing. Inside, thousands of workers and robots will collaborate, building the world's most powerful vehicles efficiently and simultaneously. The Gigabay signals SpaceX's shift from small batch creator to industrial powerhouse. But building such a mammoth factory requires tools just as impressive. A structure this vast isn't filled or operated by human hands alone. It demands a fleet of heavy machinery, the largest cranes, automated systems, and countless engineers orchestrating a ballet of construction and assembly like never before. This scale of ambition has never been attempted, putting SpaceX on a path toward redefining rocket manufacturing forever. This approach also signals a cultural shift in aerospace, moving from tradition-bound, cautious methods to fast-paced, iterative assembly lines requires a mentality embracing risk, rapid testing, and learning on the go. SpaceX embodies this through a relentless build-test-fail-fix cycle, but now with the capacity to produce many rockets concurrently, accelerating the cycle itself. It's industrial evolution with spaceflight at its core. What makes this factory so transformative is not simply its size, but the entirely new production philosophy it embodies. And overseeing its assembly is a machine of equal grandeur, the next vital piece of SpaceX's bold Florida puzzle. The gigantic LR-13,000 crane. No towering factory could function without the muscle capable of handling its colossal parts, and that's where the LR-3000 crane comes into play. This giant crawler crane is the most powerful conventional crane on Earth, uniquely suited for the Herculean tasks demanded by Starship's infrastructure. Its arrival was a spectacle, a puzzle of steel segments transported slowly over long distances and painstakingly assembled over weeks, transforming into a mammoth lifting machine towering over the Florida skyline. The LR-13000 defining mission is to lift and place the orbital launch mount, an enormous multi-level structure that will anchor the Starship and Super Heavy booster before ignition. This launch mount weighs thousands of tons and bristles with plumbing, wiring, and cryogenic fuel lines that support rocket fueling and cooling during liftoff. The crane's ability to smoothly and precisely place this behemoth is critical to building a reliable launch infrastructure capable of supporting spaceflight at an industrial scale. The crane's capacity can be illustrated by the lifting of 40 fully loaded semi-trucks at once to the total weight of approximately 3,000 tons with millimeter precision. The balance is of brute strength and delicate control, which is critical. A perfect level of the launch mount is required. Even a small misalignment could create forces that are not evenly distributed and cause a rocket to be unstable in its flight. This crane is the perfect example of the conjunction of the two incompatible traits of strength and precision, which are the main requirements for the advanced aerospace industry. SpaceX's takes here also show an operational strategy that has sharply evolved. At the Texas Starbase, two powerful but difficult-to-handle cranes worked together to build similar infrastructure which was almost perfectly coordinated between the operators. The Florida configuration is made simpler by the use of one, the strongest on Earth, the LR-13,000, thereby reducing the complexity, risk, cost, and time. This self-improvement in the process decreases the required safety margins while at the same time increasing the safety percentage. However, the LR-13,000 is not only a heavy lift machine, but a symbol of SpaceX's high self-assurance and capability. The usage of such a machine for construction is not just building, it is the control of heavy lift engineering that is rarely witnessed beyond the time-sensitive, high-stakes industries. The crane's presence is seen as a signaling of the Florida project of SpaceX being distinct in the high-tech field. However, this behemoth of technology is not primarily about power. It is a symbol of the learning philosophy that the company adopts. SpaceX draws from the past. The technical, logistic, and procedural aspects are all made to be better. Thus, no more bottlenecks or failures. This attitude is very much a part of SpaceX, so to speak, from the factory where the work is done to the place where the rocket is installed for launching. Moreover, the crane plays a major role in the establishment of the whole industrial ecosystem in Florida. If there were no such lifting capacity, the very ambitious Gigabay factory and launch pad renovation would not be made possible at all. The LRR-13000 is equally important as the rockets. It is the machinery that will eventually bear the weight of these colossal vehicles taking off. The giant, with its massive but slow grace, is already giving the world a hint of what to come. It is converting engineering power into progress that is very logical to follow. Little by little, every part lifted is getting us closer to the new world. With such infrastructure forming, it's no surprise that SpaceX chose to rebuild one of history's most iconic launch pads as the foundation for its future. Rebuilding Launch Complex 39A. Launch Complex 39. A at Kennedy Space Center is hallowed ground. This very pad launched the Apollo Saturn V missions that first put humans on the moon, and decades later, it supported the Space Shuttle program. It's a site steeped in history, carrying the echoes of humanity's greatest space achievements. Now, SpaceX is transforming it once again, preparing it to support the fiery power of the Starship system. The challenge is monumental. Starship's combined thrust from 33 Raptor engines on the Super Heavy booster dwarfs that of the Saturn V's 5 engines. The vibrations, heat, and sheer force during liftoff will far exceed anything this pad was originally designed for. The structures, even robust as they were for shuttle launches, would have been destroyed without extensive modernization. This total rebuild incorporates operational lessons from Starbase in Texas. The flame trench, originally made to direct exhaust safely away, is being completely reimagined as a survival system. It now channels energy and superheated gases more effectively, protecting not only the pad, but the rocket itself. 4 massive leg supports have been constructed, complex hydraulic pillars engineered to absorb intense launch forces. They act like giant shock absorbers, preserving structural integrity under conditions previously thought unmanageable. Key to protecting the pad area is the water deluge system. During launch, this system will unleash millions of gallons of water within seconds, mitigating extreme heat from burning fuel and drastically reducing acoustic energy. The roar of Starship's engines is so fierce that without this deluge, the violent sound waves could damage the rocket's delicate systems. The integration of massive water tanks and pumps is a feat of civil engineering as vital as the steel and concrete beneath it. Known as Pad B, this rebuilt 39A incorporates improvements such as tougher steel, advanced welding, and smarter pipeline layouts based on failures and successes at Texas. This isn't a haphazard retrofit, but a carefully engineered platform optimized from the ground up to meet Starship's demands. The difference is akin to switching from a prototype car to a fully production-ready model. Every weakness analyzed, every detail refined. Surrounding 39A, a tank farm sprouts, a gleaming collection of silos and storage vessels housing the supercooled fuels Starship needs: liquid oxygen, methane, and nitrogen. These elements will be piped with precision timing to feed the Raptor engines. Notably, the methane fuel aligns with Musk's vision of in-situ resource utilization on Mars, emphasizing the interconnectedness of pad infrastructure and mission goals. Remarkably, all this massive construction continues while Falcon 9 and Falcon Heavy rockets launch routinely just a few hundred yards away. Coordinating heavy construction, rocket assembly, and live launches demands ballet-like logistics, ensuring safety and minimal disruption. This simultaneous operation is unprecedented in scale and complexity. This transformation guarantees that 39A will not only honor its historic legacy, but also serve as a springboard to humanity's next giant leap: Moon, Mars, and beyond. It's a striking symbol of continuity and reinvention, linking past triumphs to future possibilities. Such visionary groundwork, combined with revolutionary manufacturing and heavy lifting, sets the stage for one of the most unique innovations of SpaceX's vision: the booster catching arms. The Chopsticks booster catcher. One of the most dramatic innovations at SpaceX's Florida site is the mechanical marvel known as the Chopsticks, giant robotic arms designed to catch the returning super-heavy boosters as they fall back to Earth. While the name might sound playful, the purpose is profoundly serious: to make Starship's massive boosters reusable with unprecedented speed and reliability. Catching a 230-foot-tall rocket falling from the sky is an engineering feat bordering on the impossible, but SpaceX has turned it into a tangible goal. The Chopsticks are attached to a platform called the carriage, which runs along rails on the launch tower's side, allowing precise vertical movement. Each arm can open wide to receive the booster, then close in around reinforced pins protruding from the booster's sides. This grip isn't just firm, it's engineered to absorb shock delicately, so the immense kinetic energy doesn't damage the rocket or the arms. The hydraulic systems act much like a baseball catcher's glove, moving backwards slightly to soften the impact and bring the booster to a smooth stop. Cuando se habla de un cohete que aterriza de manera normal, that immediately vacates the stage for reconditioning and fast turnaround. Each successful catch yields very valuable data regarding the angles, speeds, and movements during the final seconds of descent. The data has been utilized to enhance both the software and the hardware. Hence, the iteration gets cleverer and the reliability increases every time. The breakthroughs at SpaceX's Texas Starbase are already a strong demonstration of success. Several boosters have been successfully caught, proving that the dream of rapid reuse is not only a vision, but an operational reality in the making. These groundbreaking technologies are not merely steps forward in the production of rockets, but are able to entirely change the picture and reduce costs by lowering turnaround times and the price of launches drastically. The Florida space facilities are already training their staff to adopt these new techniques, and soon, the chopping arms will be a standard part of the operation, instead of being regarded as experimental devices. The software controls will be more precise, the hardware will be more robust, and the operational protocols will be adjusted to make kicker retrieval as common as the passenger landing at an airport. This combination of execution and innovation is the quintessence of SpaceX's move fast and learn philosophy. On the contrary, the Chopsticks are not a sudden fix for one launch pad only. More Chopstick sets are being made at SpaceX's Roberts Road facility, where they are going to be used in the coming launch sites such as Space Launch Complex 37. This points to a bigger plan. SpaceX not only manufactures isolated instruments, but also creates a production line across the fleet for launch and recovery infrastructures. The goal is a network of launch and catch towers supporting a continuous cadence of Starship flights. This massive deployment is necessary because SpaceX's dream is to have an entire fleet of Starships, where each one requires quick reusability to keep the launch frequency up. The Chopsticks make it possible to have very cheap and very frequent space travel by cutting down on the time and the money spent on refurbishing after every mission. Indeed, they turn the super heavy boosters from high-cost disposable units into reusable ones, which are essential for Musk's vision of a multiplanetary future for humankind. Apart from the technical genius, the Chopsticks are a game-changer in the way rocket flights will be accounted for. They will no longer be tied to disposable launches, but instead to airline-like operations that would require a rapid turnaround and consistent reliability. This transition is carrying spaceflight's future with it, which is going to be less restricted and more economically accessible, with the promise of a lot more traffic in and out of orbit. From the exhilarating mechanics of the booster catchers, the narrative naturally expands to how SpaceX manages logistics across thousands of miles, linking Texas's manufacturing might with Florida's launch ambitions. The Seabridge logistics operation. While the Gigabay factory rises slowly in Florida, SpaceX is already executing a masterful interim solution that bridges continents. The Seabridge logistical operation transporting massive Starship components from Texas to Florida. This strategy cleverly compresses timelines by allowing manufacturing and launch infrastructure development to progress in parallel, rather than waiting for the local factory to complete before starting orbital launches on the East Coast. Transporting a super heavy booster, a 230-foot-long stainless steel cylinder, is no trivial task. The booster must be secured horizontally on a specialized barge, shielded meticulously from weather and salt spray. Moving such delicate, enormous structures over roughly 1,000 miles is a slow, careful process demanding expert navigation and weather timing. Storms and rough seas pose significant risks, turning every voyage into a high-stakes operation worth hundreds of millions of dollars. This maritime journey traces a route from the Gulf of Mexico around Florida's southern tip and up the Atlantic coast to Kennedy Space Center's gates. It's a grand logistical ballet involving slow but deliberate motion, special transport preparations, and synchronization between displacement preparations and launch schedules. Each successful delivery edges SpaceX closer to routine orbital flights from Florida. The brilliance of this Seabridge lies in its simplicity as a strategic choice. It allows proven hardware from Texas to start testing, gathering flight data, and validating procedures years in advance of Florida's factory reaching full output. This keeps Starship development active on both coasts, multiplying pressure and momentum to meet Musk's ambitious timelines. By shipping rockets rather than waiting to build them where they will launch, SpaceX maximizes time efficiency and operational flexibility. This prevents bottlenecks that could arise from construction delays on either coast. It also deepens SpaceX's resilience. If one site faces challenges, progress at the other can continue largely unaffected. This operational ingenuity reflects SpaceX's characteristic embrace of unconventional solutions. Rather than waiting for perfect conditions, the company builds capacity wherever it can, then unites production and launch through strategic logistics. It's a model that embraces complexity to accelerate progress. The Seabridge also symbolizes the literal and figurative links SpaceX is creating between America's historic space heritage in Florida and the frontier spirit in Texas. It merges old and new, history and innovation, established aerospace grounds with emerging industrial hubs. Coordinating these massive moving parts requires precision beyond the cranes and chopsticks. It demands a harmonious fusion of supply chains, engineering teams, and maritime operations working in near-perfect concert. This integrated approach is essential to realizing the vision of a fully operational Starship launch network. With the Seabridge securing the flow of rockets across oceans, the physical footprint of SpaceX's ambitions grows ever larger. To sustain this scale, the company's footprint expands well beyond factories and docking channels into an entire spaceport city in the making. Roberts Road Spaceport Expansion. SpaceX's vision in Florida extends well beyond a factory and a launch pad. It's the creation of a sprawling spaceport city at Roberts Road. Currently sprawling across 67 acres, this site is rapidly expanding to nearly 150 acres, a scale that reveals the true magnitude of SpaceX's ambitions. This expansion isn't just about physical space. It's about building an integrated ecosystem designed to support high-volume production and frequent launches. Central to this growth is the Star Factory, a massive fabrication complex planned to be 50% larger than its Texas counterpart. With over 1.5 million square feet of factory floor, equivalent to more than 25 football fields, the facility will house thousands of employees across manufacturing, engineering, and administrative roles. This vertical integration means raw stainless steel will enter one end of the complex. While completed, flight-ready Starships roll out the other. It's essentially a self-contained metropolis for rocket production. The infrastructure upgrades necessary for such a facility are enormous. The power alone is huge, energizing industrial welding machines, cryogenic cooling units, and large cranes. Local power grids are being improved with new transformers and transmission lines to handle these loads. Communication via fiber optic cables is being made very extensive for the purpose of real-time data transfer between designers, engineers, and workers in the manufacturing area. Utility systems that support the rocket assembly are complex, and they go beyond electricity and data. A huge water line will discharge a great amount of water over the launch pad, which is essential for cooling and acoustic dampening during the launch. Cryogenic plumbing for methane and liquid oxygen has to keep the substances at temperatures around -273 degrees Celsius, requiring very exact engineering and constant monitoring. The whole network of pipes and wires is hidden, but it supports a very advanced and high-tech production environment. The choice of the site reflects a mixture of practical and strategic factors. Florida's closeness to the equator gives a natural benefit because of the Earth's rotation. Thus, rockets fired from here are able to carry heavier loads more economically. Kennedy Space Center already has a trained labor force that is familiar with aerospace operations, ranging from welding stainless steel to controlling launch sequences. Political backing, along with infrastructure, make it a perfect place to increase the capacity of production and launch. Roberts Road is a launcher that is able to carry out the most amazing launches. Instead of waiting for a couple of yearly missions, the road is ready to take care of several Starship launches on a weekly basis. This high launch frequency is a must for bringing in the great number of operations that are planned for continuous lunar bases and even a Mars settlement. The whole thing is not just a factory, it is the industrial soul of the coming space age. Going to such a height involves difficult logistical problems that are not only of a construction nature. The keeping of thousands of workers, the scheduling of raw materials deliveries, and the control of safety issues across such a gigantic and multi-use place present operational challenges of great complexity. Each single new structure and pipe must be incorporated in every single operational web that is composed of space and timing, where interdependencies are critical. The growth that comes along with the expansion is a blessing for the local economies, as it not only creates thousands of jobs, but also diverts innovation to other industries such as robotics, materials science, and propulsion technology. Thus, this development firmly places Florida at the forefront of the future space economy and becomes the new place for the training of the next generation of rocketeers and engineers. From giant factories to bustling spaceport cities, SpaceX's Florida ambitions set an exciting stage. But even as structures rise and visions expand, significant challenges remain that will test the limits of engineering, regulation, and finance. Technical and regulatory challenges. Building the world's most advanced rocket production and launch complex is only half the battle. Navigating regulatory and technical hurdles is equally daunting. Before a single Starship can lift off from Florida, SpaceX must obtain a launch license from the Federal Aviation Administration. This process involves preparing and completing a comprehensive environmental impact statement, a multi-year study evaluating how rocket launches will affect local ecosystems, air quality, noise levels, and nearby communities. Launch Complex 39A sits adjacent to sensitive wildlife refuges and historic sites, making the environmental review particularly rigorous. Any significant concerns could delay operations or force costly changes to launch procedures and infrastructure. This regulatory checkpoint is a critical threshold SpaceX cannot bypass, demanding both patience and adaptation. Beyond paperwork, technical challenges loom large. One of the most complex is orbital refueling. For Starship to reach destinations like the Moon or Mars, it must rendezvous with another spacecraft in orbit to transfer hundreds of tons of cryogenic propellant. This delicate, untested procedure involves precision docking and fluid transfers in zero gravity, a feat never accomplished on such a scale and critical for extending mission ranges. Life support systems pose another formidable barrier. To sustain astronauts on long-duration missions, Starship must reliably shield against cosmic radiation, provide breathable air, manage waste, and maintain habitability through Martian dust storms and extended sunlight exposure. These are unsolved engineering puzzles being actively researched and developed. Financial challenges compound the technical ones. Developing and deploying the entire Starship infrastructure demands sustained, unprecedented capital investment from a commercial entity. Funding construction, testing, and human-rating flights requires managing risk while simultaneously pushing ambitious timelines against fierce competition. Speaking of competition, SpaceX operates within an increasingly crowded field of commercial and national space agencies racing to define the future of deep space exploration. This competition accelerates innovation, but also highlights the uncertainty and difficulty of establishing reliable, cost-effective space transport. At the same time, SpaceX's ambitions are deeply intertwined with NASA's Artemis program. Far from adversaries, they are collaborators in many respects, with SpaceX providing launch capability and spacecraft to support NASA's plans for moon landings and beyond. This partnership brings resources, credibility, and shared stakes in mission success. Recognizing these challenges is not to dim the excitement, but to frame the scale of what SpaceX is attempting. The path from construction site to operational spaceport is a complex, high-risk journey requiring careful navigation of technical, regulatory, and financial obstacles. Even as the Gigabay continues to rise and launch pads transform, the hardest parts of this space revolution still lie ahead. SpaceX's role in the new space race. SpaceX stands not merely as a private company, but as a powerful force shaping a new era in space exploration. Its bold initiatives in Florida and Texas are part of a larger global competition to establish dominance in deep space. Countries and companies worldwide are investing heavily to craft their own pathways beyond low Earth orbit, pushing innovation and raising the stakes for all players involved. This intensifying race fuels rapid advancements, but also underscores the immense challenges still to come. Yet, SpaceX's approach differs from many traditional aerospace entities. It embraces a philosophy of rapid iteration and aggressive scaling, using industrial efficiency combined with technological daring. This has disrupted decades-old norms about how rockets are designed, tested, and launched. SpaceX's success in reusability and mass production threatens to redefine cost structures and timelines throughout the industry. This disruption also affects the interaction with NASA. Rather than being simply rivals, SpaceX and NASA have a multifaceted partnership. The agency pays SpaceX to deliver cargo and astronauts to the International Space Station and also counts on Starship development as one of the main factors of the Artemis moon missions. SpaceX is, in a way, a NASA heavy-lift rocket maker, which enables the interplay of public and private interests, as well as their acceleration, to occur. Countries like China, Russia, and other developing space programs keep their eyes on the situation globally. The competition to get to the Moon, Mars, and commercial space infrastructure is unending. SpaceX's successes have established a new standard, and others are being challenged to come up with new ideas, or they will be left in the dust. This type of rivalry is considered to be the main factor in propelling space-based technology forward at an unmatchable rate. Nevertheless, the contest is not merely over swiftness or size. Sustainability and finance have been gradually and stealthily becoming the critical metrics of the battleground. SpaceX's control of quick reuse and mass production could be a game-changer by dramatically reducing costs and raising the number of launches. This may result in a transition of the debate from who can create the biggest rocket to who can create the smartest and most efficient fleet. Besides its technology, SpaceX's cultural impact is altering the very way space missions are viewed. The firm embraces the idea using a boldness that, instead of dreaming of Mars colonization and the founding of a multiplanetary species, which used to be considered only a tiny fringe dream, has turned it into a core objective already reached by humanity. This vision not only attracts investors and engineers, but also the entire community of fanatics and policymakers. On the other hand, these ambitious objectives have their accompanying enormous risks. A combination of technical cyber problems, regulatory holdups, and monetary strain could slow down or even stop the progress of SpaceX. The company will be forced to keep on innovating while at the same time managing the huge complexity that comes with its projects. The final result is still unclear, but the scope of the aspiration guarantees that the whole process will not only be a part of history, but will also redefine the human spaceflight history. In this risk-laden situation, SpaceX's development in Florida becomes a major testing place through which the company can prove its capability. The Gigabay, improvements of the launch pad, and the all-in-one spaceport city are all being built as part of a concrete promise to keep this new space age going. Should these activities go as planned, they will not only be the foundation of America's continued domination, but also the spark that will revitalize an industry that has been under government control for a long time. Thanks for watching this deep dive into SpaceX's monumental push in Florida. From the staggering scale of the Gigabay to the revolutionary boosters and the grand vision for a new spaceport city, the future of space travel is being built right now. If you enjoyed this exploration of space innovation, don't forget to like, subscribe, and hit the bell to stay updated on the latest in aerospace breakthroughs.